Hello students, welcome to the next lecture of the mathematics. Today we will start a new topic, that is hypothesis testing. So first we should know what is this hypothesis testing. You must have heard about the new researches, where the scientists and researchers try to find out some new findings or try to find out some truth. For example, uh, you must have heard that there are lots of surveys being done. For example, we would like to know that in a college, how many students likes to drink coffee in comparison to tea. So what we'll have to do, we'll have to perform a survey. We'll have to go to each student and ask the student a question that whether do you like coffee or tea. Then based on that data, we will collect this information from all the students, and then we will try to find out some constants, that is we had already studied mean of the information or standard deviation of the information, and we will try to draw the curve, normal curve, and with the help of these information we would be able to conclude that how many students like to drink coffee as compared to tea. Before we'll start the survey, we will have an assumption. For example, let's say I have an assumption that 60% students like to drink coffee over tea. So this assumption is known as the hypothesis. Now I will need to test this hypothesis with the help of the survey and with the help of all the constants that I have calculated from the data, for example the mean, standard deviation. So that testing is known as the hypothesis testing. So I'll assure that what I have assumed, whether it is right or wrong. If I have assumed previously that more than 60% of the students likes to drink coffee, and that comes out to be true in my survey, then I'll say that the hypothesis is accepted. And if I'll see that this does not comes out in the survey, and survey is something different, the results of the survey are something different, that the lesser than 60% students like to drink coffee over tea, so I'll say that my hypothesis cannot be accepted, right? So for that purpose we need the hypothesis testing. So before we move on to the hypothesis testing, let's talk about some definition that are related. First is population, also known as the universe. So what is population? The group of individuals under study is called population of or this is also called as universe. For just I have taken the example of the college. So if I'll consider each student of the college, so all students of the college will be termed as population. That is the universe of my study. Next is sampling. In many cases, it is not possible to collect the information from all of the universe or from all members of the population. So in that case, we have a technique that is called sampling. So what is sampling? Apart from the population is called a sample. So let's say if in a college there are 5,000 students, and if we select only 500 from them for our study, that means we will go to only 500 students and will ask questions to them. So that is known as a sample. And now the process of selection of a sample is called sampling. This is how we are selecting those 500 from the 5,000 students. This process will be called as a sampling. For example, I have a criteria. Let's say I choose a criteria that I'll take all the students whose first name begins with a letter A, B or C. So this is my criteria. So the process of selecting the sample, this is known as the sampling. The other way, I can choose a random way, like randomly I choose 500 students from all 5,000 students, so that will be a random sampling. So this is another method of performing sampling. So what is sampling? Sampling is the method or is a process by which we are selecting a sample from the population. And selection of a sample is also very important thing, because your study, the result of the study will based on that sample, and the test of that study will can be applied onto the whole population or not. So this will be a big question based on the sample. Parameters. What are the parameters and statistics? To study that sample, or to study that population, we would be finding some statistical parameters. For example, let's say mean, standard deviation, and other parameters. So these are called as the parameters. Now let's move further. Types of sampling. We don't have to study types of sampling in detail in this lecture. We will study this maybe later in some other subjects. So for name, purposive, random, stratified, and systematic. I had given you an example of the random sampling, where randomly I can choose 500 students from a population of 5,000 students, right? Now let's talk about the hypothesis. Testing of hypothesis. Coming to the main topic, testing of hypothesis. So what is testing of hypothesis? As I have already told you, what is hypothesis? Hypothesis is the assumption that we try to test on a population, on some criteria, on some topic. That will be the hypothesis, and these assumptions are known as a statistical hypothesis. The hypotheses are tested. Assuming the hypothesis is correct, we calculate the probability of getting it as a desired sample, or observed sample from the observed sample. So if this probability is less than a certain assigned value, the hypothesis is to be rejected, right? So we already have some probability criteria. If the resultant of that test is less than that particular probability criteria, so we will reject the hypothesis, and if it is greater, then we will accept. So depends on the probability value. If it is less than, then we will reject, and the calculated value is greater than, then we will accept. So there are lots of types of hypothesis. Let's talk about one, that is your null hypothesis. Null hypothesis is based for analyzing the problem, and null hypothesis is the difference is can be to study the difference or significance difference between two observed samples to expected values, or to approve or disapprove an assumption. That is a null hypothesis. Error. What is error? In sampling theory, to draw a valid inference about the population parameter on the basis of sample result, whether we decide to reject the hypothesis or to accept the hypothesis. So there are two types of errors in reference to the null hypothesis. If the null hypothesis is rejected while it should have been accepted, then it is known as type 1 error. And if a null hypothesis is accepted while it should have been rejected, then it is called as type 2 error. So we have two types of errors. Type 1, when the null hypothesis is rejected while it should have been accepted, and type 2, when null hypothesis is accepted while it should have been rejected. Now let's talk about level of significance. So there are two critical regions which cover a 5% and a 1% areas of the normal curve. These are the shaded regions, which are known as the critical regions. So this is the area of the acceptance. Please remember these values. Z is equal to 1.966, Z is equal to 1.966, and Z is equal to, this is onto the right hand side, 1.96 is for a symmetric normal curve. So these are the values called as the level of significance with which we are going to compare our calculated value. And if our calculated value is less than this value, let's say at 5% significance, 5% level of significance, the value is 1.966. So if the calculated value is lesser than 1.966, then the hypothesis will be accepted, and if it is greater than 1.966, then the hypothesis will be rejected. Similarly, for some other level of significance, this is for 0.25, 2.5% level of significance, this is 0.674. So we'll see this later in the questions. We'll cover this part in the questions. It will be easier for you to understand. Now let's talk about the one testing that is known as the T testing, T students testing, also known as a T test. So this is the T distribution for small samples. The student distribution is used to test the significance of the mean of a sample. This is the first purpose why we use the student distribution to test the significance of the mean of a sample. Let's say if we have 10 observations and we assume that the mean of those observations is 67, then we can test with the help of T distribution whether our assumption is right or not. So just to test the significance of a assumed mean of a small sample. Then the difference between the means of two small samples. So if we have two small samples and we need to compare the difference between the means, then we use T distribution, and we'll use to test the significance of the correlation coefficient. So these are the reasons why the T distribution is used. This is the formula for the T distribution we need to keep in our mind. You can copy this formula in your copies. T is equal to x bar minus mu divided by s upon under root n. Where s is the standard deviation. We had already seen the formula of the standard deviation. So you need to keep this in your mind, the formula of the standard deviation. So we need to calculate this T and compare the value of this T by the standard value, and depending upon we'll give our result of the test of significance. Let's see an example. A machine which produces micro-insulating washers for use in electric device with the thickness of 10 mm. A sample of 10 such washers has an average thickness of, this is the average thickness is being given, 9.52 mm with a standard deviation of 0.6 mm. Now you need to find out the value of T. So we must identify what the values are given here. So let's see, x bar, the assumed mean has been given 9.52 if you'll see in the question. So it was 9.52 given. M is the total number of observations, that is thickness 10. Then standard deviation is being given 0.6 in the question. N is the number of items, that is the observations, or we can also say the sample size, the number of items into the sample. So this has been given a sample of 10. So we have all these values. We need to substitute these values into the formula and to calculate the T. So you can see this is how we can calculate the formula of T is x bar minus m upon s upon under root n. So this is the value substitution. We have substituted all the values and we obtain the T as minus 2.528. So as there is no standard value is given, so we cannot conclude any result about our assumption, but yes, we can calculate the value of T in this question. Now let's go to the second question. Let's see question number 77, example 77. Compute the student T for the following values in a sample of 8, taking the mean of universe to be 0. Again, we'll have to calculate T only. So where we have given the sample of 8, so the sample size is 8. These are the values, and mean has been given as 0. So we'll construct this table with the values, and we'll find out the required columns, because we need to calculate the standard deviation for our formula t. So we will be calculating these two values so that we will be able to calculate the standard deviation. So this is how we could get the values. So we will find, what we will be finding is x bar from the table, standard deviation from the table. We had already done all these calculations previously, so we know how to calculate a mean from a given data, and we know how to calculate standard deviation for a given data. So mean and standard deviation we had calculated. Then we will substitute these values into the formula t, where mean is 1 upon 4. The mean, assumed mean into the question was given as 0. The mean of universe is being given as 0, so we have kept it 0 here. Standard deviation we had calculated 2.66, and n, that is the size of the sample, this is 8. So just by solving these things, we get as the result t is equal to 0.266. So till now we had already calculated the values of t. Now we will come to some questions where we will find the text of, we will actually perform the test of significance, that we'll do into the next lecture. That's it for the day. Thank you so much.